You've seen them, right? The incredible AI demos, those impressive pilots that promise to change absolutely everything. But here's the hard truth. When these projects actually move from the lab into the real world, most of them fail. And the reason is simple, but it's the most overlooked part of building with AI: operations.
And that really is the core idea we're digging into today. You see, the genius isn't just in training a model to do something cool. The real challenge, the place where all the value is either created or, well, destroyed, is in running that model reliably, safely, and consistently, day in and day out.
Okay, so let's break this down. In the lab, you're focused on a few clean metrics. How accurate is it? Is it fast? Can it give you that wow moment in a demo? But out in the wild, the rules are completely different. The system has to be reliable, even under chaotic conditions. You absolutely have to be in control of its behavior. And maybe most importantly, it has to be safe. This gap, right here, between the lab and the wild, is exactly where projects fall apart. Now, to bridge that gap, a whole new engineering discipline has emerged, and it's got its own critical vocabulary. We're going to break down terms like MLOps, data drift, and guardrails. And trust me, these aren't just buzzwords, they are the fundamental building blocks for running AI systems like a professional. So, here's our game plan for this explainer. We'll start with that production gap, then figure out how you control AI systems over time. We'll look at why even the best models decay, learn how to see and steer them, and finally, cover how to ship updates without, breaking everything. All right, let's tackle that first big challenge. How do you turn a powerful model into a product that people can actually depend on? This is exactly where MLOps comes in. If you've ever heard of DevOps for software, the idea here is pretty similar. MLOps basically takes those same principles, automation, collaboration, continuous delivery, and applies them to the unique world of machine learning. It's the framework for building repeatable, reliable systems, not just one-off experiments.
And with this new wave of generative AI, we now have LLMOps. Think of it as a specialty within MLOps, because large language models, well, they come with their own set of massive problems. Things like managing totally unpredictable outputs, making sure they're safe, and keeping those huge operational costs under control.
So if there's one thing to take away from this section, it's this. MLOps is the bridge. It's the whole collection of practices and tools that transforms a promising piece of data science into a tough, enterprise-grade product that people can actually count on.
So now let's get into the first pillar of real control. How do you manage your AI models with the same kind of discipline you'd use for your most critical software?
Just think about this for a second. Your AI is making decisions live, in the real world. Suddenly, it starts making really costly mistakes. How do you instantly and reliably roll back to the last version that you know worked? Without a system in place for this, the simple answer is, you can't.
And that is the job of a model registry. The best way to think of it is as a version control system, kind of like Git, but built specifically for machine learning models. It's a central hub that keeps track of every single version, its performance, the data it was trained on, and its current status, whether it's in development, staging, or out in production.
And this is what that process looks like today. Modern tools don't just spit out a model, they create an entire automated pipeline. Every single piece, from how the data is prepared to the specific algorithms used, is tracked. So the final output isn't just a model, it's a versioned, reproducible thing that gets logged right into the registry. And this really gets to the core principle. Shipping an AI system without a model registry and versioning is like trying to ship software without any source control. It's unprofessional, and frankly, it's dangerous. If you can't trace a model back to its exact data and code, you can't debug it, you can't audit it, and you certainly can't trust it to run your business.
Okay, but even with perfect versioning, every single model you deploy has a hidden expiration date. This brings us to the silent killer of AI projects: model decay.
Because let's face it, the world is not static. Customer behaviors change, new trends pop up out of nowhere, language itself evolves. The data your model is seeing today is different from the data it was trained on yesterday. So, what happens when that gap just gets too wide?
Well, this decay happens in two main ways. The first is called data drift. This is when the inputs themselves change. So, for example, a loan model might start seeing very different income levels during an economic downturn. The second is model drift, which some people call concept drift. This one's a bit more subtle. The inputs might look the same, but the relationship between those inputs and the correct answer has changed. The things that predicted a customer would leave a year ago might not predict it at all today.
And here is the most dangerous part of all this. This decay is silent. A model doesn't crash or throw up an error message when its predictions get worse. It just slowly, quietly becomes wrong, making worse and worse decisions over time. If you're not proactively looking for it, you might not even notice until some serious damage has been done. So, if models fail quietly, how in the world do you fight back? Well, you have to build systems that give you visibility and the power to enforce some rules.
See, production-grade monitoring goes way beyond just checking if predictions are accurate. Mature teams, they track everything. They're monitoring for that statistical drift in the data. They're monitoring the servers for latency and errors. For these huge models, they're monitoring costs down to the penny. They even monitor for things like fairness, to make sure the model isn't slowly developing some unwanted bias. This really is the core principle of production AI. Observability, being able to see your system, it's not a nice-to-have feature, it's the absolute foundation of control. Without it, you're not really managing a system, you're just crossing your fingers and hoping it doesn't break.
Now, beyond just seeing, you also need to be able to steer. This is especially true for large language models. Guardrails are basically automated safety systems that you wrap around a model. They analyze what the user puts in, they check the model's potential response against your safety rules, and they can either block that response or nudge it in a safer direction, all while logging what happens so you can audit it later. Guardrails don't make AI weaker, they make it usable in the real world.
Okay, we've covered how to manage, monitor, and constrain our models. Now for the final piece of the puzzle. How do you introduce a new, updated model into a live system without causing a complete disaster?
Well, rule number 1 is you never just push a new model straight to all of your users. Instead, you use professional deployment strategies. With a blue-green deployment, you have 2 identical environments. All the live traffic is going to blue. You deploy your new model to green, test it out, and then you just flip a switch to send all the traffic over. An even safer way is a canary deployment. With this, you send a tiny fraction of traffic, maybe just 1% to the new model. You watch it like a hawk. If it's doing well, you gradually roll it out to more and more users. The key is, in production, change must always be gradual. So let's bring it all home. Why do most AI projects fail? It's almost never because the model wasn't clever enough. They fail because they focus only on training and not on operations. They fail because they can't reproduce their own results. They fail because they aren't watching for that silent decay of their models. They deploy without any safety nets, and they push massive changes to production all at once.
And this is really the ultimate takeaway. In the long run, the winners in the world of AI won't be the teams with the most complex algorithms. The winners will be the teams with the most robust, reliable, and well-operated systems. So I'll just leave you with this one question to think about. When you look at your own work or your company's strategy, are you just training models, or are you truly building products? Because the difference between those two is everything.